Hello guys, I'm Prahlad Muralidharan and this is my group project, my team. So our team name is SJF. I'm Prahlad Muralidharan again. You might have seen some of these folks sitting next to me, Osman Ahmed, Arish Suryani, and Naveen Thomas. So here are group responsibilities and a group name. A group name is shortest job first. This is just like, it's a small joke, the operating systems, how it does the shortest job first. I think at the time we were learning something like that, so it just came into our idea. Anyways, the responsibility of each team member. So Naveen did the coding. Thanks to him, we got a lot done very quickly. The recording and video, as you guys see, is done by me, Prahalad, and the one-page report, which was done very nicely and done in a readable way, was done by Arish, and the presentation slides was done very clear and concise and understandably by Osman. Thanks to everybody in this team for doing the right job. Introduction. Our group is designing a process manager. The process manager schedules the system and user processes. It allows multiple processes to simultaneously share the CPUs and IO memories and resources. Our process manager will identify the system and user processes, and for each process, it will provide the CPU and IO utilization. It will also label each process as CPU bound or IO bound. Motivation and problem formulation. So our group chose this because we felt the function of a process manager is the most important to the foundation of an effective operating system. The problem that would arise in our operating system without an effective process manager would be like, it wouldn't be able to multitask anything. And in computers, we know how crucial multitasking is, because imagine our computer had to take every small step bit by bit rather than just doing a bunch of processes at the same time. That would take like forever, right? So our task is to formulate a system that can accurately allocate the CPU and IO resources for each process. So a very important thing when we're doing this is, like, we have limited resources, right? In every part of our life, we have limited resources, and we have to be able to allocate that properly, or else we won't be, when we're multitasking, or else we won't be able to multitask, basically. So method, in order to create a functional process, we must find a way to gather the data on the running processes. And the data includes name, process, memory allocation, CPU, IO. And so what we basically did is we use the information to determine if the process is a IO or a CPU bound. And the way we did this is using the psutil library in Python. So we import the psutil library, and then we use whenever you use the library, you just hit the dot. So we use psutil, which is the library, then dot, and then we have the method. So process_iter function to list the running processes. We then use process.as_dictionary, DICT, to list the data for the CPU, IO, and memory. Using an if-else statement, we determine if the process uses more CPU or IO, and then the process is labeled as such. Now, results, of course, every project has a result, right? Whether it's good, bad, no matter what. So the result is a program that can list out the memory regarding a process. These are PID, name, memory, CPU, and IO. Using this information, it distinguishes if the process is IO bound or CPU bound, and it labels it as such. So here we have the psutil. I will actually run this and show to you, but this is how we did it. So we get list of running processes, then CPU, IO, we are talking about the if over here, right? If else, and then the PID, name, CPU, we're just making that and putting that in to the array kind of thing. And then we are printing it, basically, very simple. And the results is the implementation of the script creates a functional process manager that can be used in an operating system. This function is a large part of what an OS does, as specifying while device CPU or IO, which as specifying which device to execute, and which allows for normal and intended flow of data within the computer's memory. This is one of the primary goals of an operating system. Anyways, so let's go to the coding part. So here we get the list of running processes. We see the CPU, and then we determine if the CPU is inbound or IO, and then we print it. So I can run it here and show you guys. And we see, wow, there's a lot going on right now. But let's just take one of these, the random, okay? So we have a process, random ID to a process, not random, but you know, it is random actually, yeah. And then we have the code, for example, code.exe, it shows the CPU percentage is 0 and the memory is 0.286. And obviously, since the memory is higher, the IO, it shows the IO utilization, the process is obviously going to be IO bound. For some reason, when we did the PS util, I think, we only got the IO utilization, and it always showed IO bound, because in order for to get the CPU bound, you need to have a CPU percentage which is higher than a memory percent. But for our project, mostly we just got IO bound. Like if we take another random example, take this Firefox.exe, CPU is 0, where memory percent is 0.911, and it's IO bound. So that's basically it for our project. Hope it made sense. Hope we clarified any doubts. And as for the references, Naveen did the coding, and we discussed with him, most of the coding we got from the Python libraries. So that's about it. And then most of the process manager information, we Googled it, and we found on like websites which teach about like process managing, the process manager, and which teach about operating systems. Or we actually got it from our class slides actually. So most of it wasn't anything crazy, not too much research. We just went within the resources that we had and a little bit outside the resources we had. But it was kind of hard to put an exact reference on it. So yeah. Thank you, and hope you enjoy the presentation.